All right. Hello, 7th graders. Today, I'm going to demonstrate for you how lightning is made, or kind of like how lightning is made. And I'm going to demonstrate it using a balloon and water, and I need somebody out there to help me. Is there anybody out there that'll help me? Oh, Megan! Oh, Megan will help me. Good, Megan, thank you very much for your help. She has great hair today. It's nice and clean and really long. We need to remember yesterday we talked about lightning and how the cloud was negatively charged and the ground was positively charged, and they came together to form the lightning bolt. Well, this is what it might look like here in a sink. All right. First, we've got to negatively charge our balloon. All right. So we've got to rub it on something that'll give us some static electricity. Oh yeah, that'll work perfectly. Good. Now we have a negatively charged balloon and positively charged water, and it attracts the water to the balloon because the positive charge of the water is attracted to the negative charge of the balloon. You want to see it again? My balloon back here. Really
I bet you we get a million.
Oh yeah. Yeah, there we go. And it really pulls it. Really pulls the water over. Today your groups are going to come up. You're going to have a demonstration that you're going to study and become experts on, and then you're going to show it to the rest of the class in video. All right, so let's get to work.
There you go, that was better. Oh, that actually looks cool.
The straw
You're recording right now?
the green one.
Go back out.
That's air pressure that bounces off the sides and
Wait, let me see. Basically the same thing.
What?
I'm gonna blow on these cans to see what happens. As you can see, they attracted to each other.
The reason they stick to each other is because the air pressure changes from low to nearly none, so they stick together to compensate the air pressure change. And when you blow there, it changes from the low air pressure to high, so they push away to get to lower air pressure. And that's basically how tornadoes work. So the air pressure changes rapidly, so it creates that tunnel, and then it makes a tornado.
It's science.
Today we are going to be bending a straw in water. Okay, so first you fill up a cup halfway with water, and then you put a straw in the water. And you will notice that it looks broken.
Or bent. Since the light from the straw in the water reaches observer's eye later than the part of the straw not in the water, the straw appears broken, not bent.
And this happens because light moves slower in water than it does through air, so it looks like the straw is bent.
It's not magic, it's science.
Okay, so how you do this is you just crumple up a piece of paper and you place it on the bottom. The paper watched it fly out of the bottle back towards the person who blew at it.
This occurs because of the rapid moving air that goes past the wad. It strikes the bottom and sides of the bottle. As a result, as the air pressure increases, the air will escape out, and so will the wad with it.
What do I do? What?
Upside down reflection, not vanishing reflection.
Okay, so we're going to be looking at a spoon and looking at our reflections. When you look at the back, you realize that your reflection is right side up.
When you look at the front, you realize you're upside down.
This happens because the spoon curves and the light reflections come in straight lines, and when the spoon curves, they shoot off in different angles.
Let's fill up halfway. Oh. Wait, what's this project called again? We
I have to fill a bottle up halfway, then shake it. And then I have to dump it.
What's the temperature of the water? Is it cold or hot?
It's hot.
Good.
And we have to put the cap on. Real fast. And then we can...
So then the bottle will start to collapse, and this happens because the air in the bottle turns cold instead of warm, and cold air uses less space, so the bottle will start to collapse.
What do you think about that, Christian?
Stop! My goodness gracious.
So what we have done is we have wet a bottle cap, and Sterling has put his hands on the bottle to make the air in the bottle warm.
The hot wind, since their hands are like warm, it heats up the air inside the bottle, and then when the hot air would go up, it would lift the cap up and escape the bottle.
The reason what happens is as much as Starling's hands get warm, they warm the bottle, the air inside the bottle, and it rises and it lifts the cap and gets out of the bottle.
I'm gonna blow on these cans to see what happens.